Does anyone else feel like it's Christmas morning anytime Filament's delivered? I love this stuff.
Thanks for coming by and welcome to my channel. This is video 2 in a series about my Raspberry Pi rack build. If you're just getting started, I recommend that you watch video 1. That will give you a baseline of knowledge about the project and what we're trying to accomplish here. I'll put a link in the description for you, and you can go check that out. If you're returning to the video series, thanks for coming by. I appreciate it. I hope that you get a lot out of this video today. So, today we're going to introduce a new component called mid-rack. Now, the mid-rack sits on top of your side panels and allows more side panels to interlink with that. If you are only doing one set of side panels, you won't need a mid-rack. However, if you're like me and you have multiple tiers, you will need a mid-rack structure in order to set the additional series of side panels into that. So the mid-rack allows you to essentially stack side panels. It also provides stability for the rack. Now, we're also going to talk about a parts list. So the parts list that you need to put together is based entirely on the things that you need for your rack. So if you are only doing 5U, that's going to be different than if you're doing 20. The primary components that you're going to need to buy are magnets. So I have 2 sets of magnets that I use. For this, I have a 20 by 6 by 2 rectangular magnet. And I also have a 6 by 2, which is actually 6 by 1.75 circular round magnet. Now the rectangular magnets are what's going to hold the side panels and the backs together. So that's what kind of keeps those parts together. Now, the round magnets are going to be what are used on the front. So each U has one on each side, and then each faceplate has one on each side. So depending on how many U's you use, you'll have a total of 4 per U of the round magnets, and for each section of the rack, you'll have a total of 4 of the rectangular magnets. The top also has 4 of those rectangular magnets, or sorry, 8 of those rectangular magnets, so 4 for each section of the top. In addition to that, the top will require 4 M2.5 by 10 bolts. Now, I know the machine screws, you generally don't use those with plastic. You'd want to use a nut or something like that to hold those. It seems to work pretty well without. If you want to add it, go for it. But I'm not doing that. I'm just going to go with it because it seems to work, and I don't really open the top enough for that to matter. So I would recommend that you pick up a little packet of the M2.5 by 10 bolts. I like stainless, that's just me. And then, depending on how big you want to build your rack, you're gonna have to calculate how many magnets that you need. So again, each section will require 4 of the rectangular 20 by 6 by 2 magnets, and each U will require 4 of the 6 by 1.75 magnets. So I'll throw that out in the description as well, just so you can reference it there, but that is your parts list. Now, let's talk a little bit about aesthetics. So the outer surfaces of the rack are the ones that build on the build plate of your printer. So depending on the texture or the smooth surface that you want, the aesthetics of your rack, that's going to influence which build sheet that you use. Now, I tend to like the textured sheets. I think they look better for this print. Some people probably like the a smooth texture instead. Either way, however you want your rack to look is what you need to purchase or run off of your printer. So the 2 primary sheets that I use for a textured surface are the Prusa textured sheet and the King textured sheet. Now, for this build, I've switched pretty much exclusively to the King's build sheet because it just seems to hold better with this PLA. As many kind of hard edges and angles as I've got on this, it just seems to work better for this. Now, the original rack that I built, I used the Prusa textured sheets. I had just got them in, and I did have to go through some extra plastic in order to get those things to sit down. Once I figured it out, it works pretty well, but I've added a bunch more hard angles to this as part of the dovetail interlocking mechanism, right? Or I guess the tongue and groove, whatever you want to call it. Anyway, the addition of those hard angles made it significantly more difficult for it to stick to the build plate. So again, if you're having adhesion issues, just go ahead and go with a smooth sheet. You may want to sand it and paint it afterwards, depending on how your first layer's dialed in. But for me, I'm going to go with a king sheet, and that's what we're going to go with. It seems to work pretty well. I've printed a number of parts, including the base and the mid racks from this. What's printing behind me right now is one of the side panels, so you'll probably not get a sneak peek of that in this video, but at the very least, it's printing and it's in the works. So anyway, let's go ahead and jump into a screen recording and I'll show you what's up. Okay, so what we have here is the mid-rack structure. So this is what's going to sit on top of your side panels and then allow you to stack another set of side panels on top of that. So if you look, these two here in the middle, that is what's going to be essentially the top of the side panels that meet into the bottom of this. And then here on the top, you've got these three sections here. So what you'll see when you see the side panels is the side panels have 3 pegs on the bottom and 2 pegs on top. That's because of this piece and needing the spacing to allow for multi-stacking. So if you see, there's also an interesting feature here. So on the tops here and on the bottoms here, you have a 1mm chamfer. And when you 3D print something like the side panels where you've got those kind of pegs sticking out, a lot of what you see kind of in those tiny little edges, the 90 degrees between where the pegs come out and where the bottom of the side panel stops, that, with a 90-degree angle on a 3D printed object, generally there's some artifacting and it's not a completely straight surface. So what these do is allow for a little bit of variance in between where those pieces meet. So I find that it makes everything fit a lot better. If you look at the base, you'll see that I did that as well on the base. It just makes everything fit so much tighter, and you can barely even see that it's there. Anyway, I put a little bit of kind of cross structure in here, not necessarily for strength, because this thing's pretty strong anyway. What that's there for is essentially cable management, right? So if this is the back, you've got wires running up through the back, that just kind of keeps them in place a little bit better. And then, if you need to run wires up the sides or whatever, I don't recommend doing that because you wouldn't be able to pull the blade out, but if you did, it would keep it kind of in its own little compartment. It just makes things a little bit easier to work with. I'm sure it does add a little bit of strength too, but it is very rigid. It wouldn't be necessary. The thing's pretty strong. Anyway, let's kick it over to the slicer and then we'll get it sent out to the printer. Alright, so we're over in PrusaSlicer now. Again, I use PrusaSlicer. It just fits my workflow better. Let's go ahead and rotate this thing. There we go. Okay, so rotate it, center it, set this for Prusament PLA. Where we at? There we go. Okay. 2 quality, set for the right printer, no supports, 15 infill. We'll set this to 5 bottom and 5 top. And we should be ready to slice. Alright, so 3 hours, 36 minutes. That's not too bad. Alright, let's get it going.
Alright, here's the mid-rack. So, as you can see, printed well. All the angles held. No lift off the bed. This is the way it'll sit, by the way. So these sit on the bottom. So that'll sit on top of that. Then more will sit on top of this. You won't need one of these on the top of the rack though. So on the top of the rack, there's actually a whole nother component that sits up there that has some hinges on it for the top. So this is really only used for sectioning off and securing the rack vertically. But came out really nice. Good texture. Okay, today I'm going to walk you through a couple of things. So first I'm going to walk you through what I originally started with, because I think it's still a cool design, it just didn't fit the needs that I had when I designed the new rack. So if you look, I actually have a flip top here. That's for the two 40mm fans. Of course, a little bit of access in here so I can plug those into the Pi that sits on the top. And I think I had up to 5 in a rack at one given time throughout this. And of course, this was the blade that goes in there. So you can see you actually have access to a lot of the components. And that's for airflow. So this is a negative airflow component. So you pull air out the top. Of course, this sits over here where you detach another Pi fan. Now that Pi fan will pull air about 50-50 from this side and up from the bottom. So when it sits in here, based on my smoke tests, it worked pretty well. But like I said, it was too small for my use case. So it came in through the side and then hit this fan, went up, and then the same from the bottom. Of course, that would go out the top. And I even have magnets in here to hold this top on. However, things didn't fit quite as well as I'd liked. It's still a usable rack. I'll probably throw something on it at some point. But, you know, it isn't what I was looking for. I wanted something a little bigger and a little more self-contained. Now, what we have here on the table is the beginnings of the new rack. So here we've got the base component, and I'll have side panels and a back panel here. Then I'll have a mid-rack. Now, this section is going to be new. So this section is going to be a management cluster. So I'll still have my 2 storage racks here that I'm going to use for breadboarding and stuff like that. And at some point I may throw something in there that's x86, you know, AMD 64, something like that, in order to run something like, you know, OpenSense. I just haven't got the hardware for it yet. But here, this is going to be 3 new Raspberry Pi 8 gigs, 4 Raspberry Pi 4 8 gigs. Those are going to run a Rancher management cluster for me. So it's still in the experimental phase from what I was reading on their GitHub, but I want to have a management cluster that runs things like Vault and Rancher and kind of the management and monitoring utilities. I'll probably run something like Jenkins to execute Ansible scripts, but for the time being, I've been running those on the VM on my Synology. I'm not particularly happy with the performance of that or the redundancy of it. So this will be a whole new section of the cluster, and then the cluster that I have now will go here. So I'll have 5 Raspberry Pi 4 8 gig systems. Those will be part of this, and you'll see I'll have all the components laid out here. This will be the display system, and then over here the top of the rack. But anyway, the new design is going to have an extra tier in it, and I think it's going to be pretty cool because I'm going to do some design changes to the face plates of these. Maybe some color changes or something like that. But those will look pretty cool when they're done. And then of course I still haven't started work on the top of the rack yet as far as fitment with the new interlocking mechanism. So you can see these are all ready to go. They're all pristine. No edges lifted or anything like that. They all look pretty good. So I'm happy with this result. So we'll see where it goes from here.